We are thrilled to have Dr. Sharon Tsao here today with us. She is an assistant professor and the David Packer Endowed Junior Fellow in the Department of Computer Science and Engineering at Santa Clara University. Her research creatively applies AI and HCI approaches for researching effective technologies to help people learn, and she's made important contributions to many areas, including innovations in computational modeling of educational data, visual analytics, and adaptive technology for personalized learning. She's also a co-organizer of the Educational Data Mining in Computer Science Education Workshop series, and I truly cannot think of anyone better to speak to us about recent advances in user modeling about how students learn to program. We're very grateful that she's taken time out of her busy schedule to be here with us today. And without further ado, I am going to hand the floor over to Sharon.
Thank you. Thank you, Alyssa. Do you see my share screen now?
Yes, we can.
Perfect. Let me close out this part. Somehow I have the participants' windows right in the middle of my presentation. Okay. So thank you, everyone. I'm very happy to be here to talk to you about the data-driven engineering, particularly in programming language learning. So yes, I love coding. I feel very blessed to be able to research in the field and happen to be something that I'm passionate about. So just to give you a quick background, for the past 10 to 15 years, I actually have been working on programming language learning from the user modeling perspective, from learning and analytics perspective, and center around computer science education, particularly in programming. And I built a lot of tools, educational technology tools, to analyze it, to see multiple different facets of the data that we could collect, that we could infer in learning, particularly in the context of programming language. So today I really just have two parts. The first part, I'm going to introduce you this paper. As you can see, this is a 2015 paper, which gives you a very good overview for at least the recent decades of literatures, particularly in programming language learning. And this was done by the collaborations with the European groups and also American, the US groups. They worked on the survey for the past, well, before 2015, for about 3,000 something papers, and 76 of those articles were actually analyzed systematically. And this actually covers quite a range of the students, 265,000 of the students in the programming classes and how they learn. So one of the biggest categorizations for this article talks about the data collected and what types of data. Then you can see from the low level keystrokes to the higher level from the entire program code submissions. So if you look at the trends, you see over the years, people are concerned and more different types of data could be collected down to the scrolls, to the words that you typed, or just pieces of a code, or just eventually the correctness of the compilations of the program. So they do these categorizations on all the work before 2015, well, 2005 to 2015, and put it into the three categories. The first category is focused on the students, including students' knowledge to students' behavior specifically. And the big chunk of that is on the environments, the tools they have been using to help them code. For example, the algorithms, the unit testings, or the auto analysis, auto feedbacks generations to analyze the codes, the environment in general. And lastly, it's in the context, the programs. It ranges from the Java, C, to Pythons, to SQL. So that comes into the details on the program codes, the compile, the debugs, the bugs, the mistakes, the syntax errors, and to essentially all the sources that's combined. So I enjoyed this article very much, and I highly recommend. So the only thing that I will look at it differently is I find such categorizations focus more on how we code, right? So this is taking into the software engineering perspective, how user use the tools, how they interact with the tool, right? So that focus on the environments, the tools, and anything in between, right? So this is terrific. But today, what I would like to talk to you is actually look into all these works, but into the different perspective on how we learn. So that I'm going to use the user modeling perspective from the context and the learner, the students, just two dichotomies to analyze all these works. So to begin with, that I would like to mention that programming language learning and the programming learning analytics community do not grow overnight. 10 years ago, we actually started these workshops in AI Ed conference. And then we got a lot of attractions and popularities, and mainly because, you know, about that time, 2013, 2012, there was a huge push on the CS for all, right? So the computer science, one of the backbone skills on the programming, it's being pushed to a wider audience, to the even younger crowd. Right, so after the workshops, we immediately put out a call for the special issues. We had roughly about 30 submissions. We ended up published 8 articles, and ranging from the different modalities to the context. So you could see in 2015, that's where the literature review came in for all range of the articles. So through that, communities from ICTC and SIXI, which is the special interest group in computer science education groups, there is a subgroup focused on the challenge at a time. Once we are able to collect that massive amount of data, then we need a standard, we need a protocol, and we needed more infrastructures to guide how we push this effort forward. So after that, in 2015, until just a month ago that we wrap up the 7th time of the CS EDM workshops, it's mainly sponsored by this Splice group. And throughout the past couple of years, we put out 2 data challenge. The first one focused on student modeling. The second one focused on the modeling techniques. And just a month ago, we are able to finally publish these 3 articles in special issues, which focus on one, the challenge of the data, the second one, the pair programming, the different modalities, how you work with the people, which in realities in industries that a lot of the time you have to collaborate on the larger scales of the program. And the third is about the predictions techniques. So none of this work would be complete without, you know, mentioning all my colleagues and peers, including several of my students too, and they are on the job market. So to put it in, finally, that I really wanted to do is talk to you about programming learning analytics in how we learned from the user modeling perspective, specifically on content model, and the other part is to model the users, model the learners, the students. So the reason of looking at the literature and all the research studies that we could do, putting in these 2 perspectives, 2 labels, is mainly thinking about how learning is challenging. It's complex. It's not just about the tool, we could invent any other new tools, but the fundamentals is about the context itself and also how people learn. So the first thing on the contents, several of my past projects and also current projects. The first part is about the language, the context itself, right? Includes the code snippets and the errors, the syntax errors, and potentially the comments, the partial natural language combined in between. And if you look at the programming languages, this is not far away from the knowledge representations in programming using the abstract syntax trees or the ontological methods to represent the domain. But a big part of the contents actually coming from the peripherals contents, the hints, the feedbacks. Thomas groups from North Carolina work a lot about that, and how people organize the nodes and pseudocodes, and also discussion forums, right? How people look at the informations provided out there and search for them. So essentially, the content itself actually expanded a little bit on the programming language per se, but also look into the peripheral contents. The other part of the students' model is look at the users' analytics. And this covers the learning assessments, the learning methods, learning behaviors, which is take into account the learning theories on behavioralism. How do we approach the context, how we actually adapt and change behaviors on how we solve problems, right? So this actually covers quite a range of the analytics here, from the state and the visits, the reflections, the content generated, and evaluating the success. And the middle part of this is the learning analytics about the methods, the different modalities, how we collaborate with people, how we actually incorporate the more abstract levels, the concepts, other than syntax and semantics, but actually computational thinkings, broader abstract concepts, and the strategy that we take to solve the problems. And lastly, is actually a big focus on the learning behaviors, including the help-seeking behavior, troubleshootings, information seekings, the affects, and persistency. And I remember we did this information seeking project, mainly discussed that how people look at the Stack Overflow, which is a very commonly used public discussion forums centered around the programming. And that was actually inspired by Alyssa's work on the listening behaviors, that people do not actively participate on the discussions, but they are also the key player because they consume all those informations silently, quietly, and listening to all those discussions going on. So I only have a few minutes left. I'm trying to talk one example that will hopefully touch upon, the contents and student models and give you a little deeper context. Oh, just to mention, the reason Copilot with the AI inference essentially was something pretty much discussed in 2012, 11s. The intelligent tutors designed for programming language learning essentially take into account these two parts. And I look forward to see more work focus on the content and students, but particularly work around Copilot tool. So one of the tools that we have to investigate how students solve programming problems is called Quizlet. If you look here, the questions being asked is just the operator about the definitions. And we designed this tool provided for lower programming language courses, about 600 users per semester. And each part of the design actually leverage the learning sciences principles, including the distributed practice and the retrieval practice, how frequent they use it and how they chunk it into sections and how they reflect, and in order to enforce the metacognitions, and how they actually leverage the peer feedback, etc. So this tool, that just imagine, you have never seen it, that's fine. Imagine as any other course management tools that allows you to put up the learning managed, yeah, any learning contents, a piece of a content. Could be a question, could be assignments. And we break it down the data logs into essentially trying to identify the context in programming. In our case, it's more straightforward because it's easier to focus on middle part, which is the programming questions, programming content. So in this way, then we could actually engineer the feature, particularly represent the programming problem. In this case, the contents will be represented based on the complexity, easy, moderate, or difficult. And the correctness of the questions will be labeled as 1 and 2 to see whether it's correct or incorrect. And the amount of the time extracted from the timestamp, the logs from the data. So it's very straightforward, just 3 key features so that we could re-engineer all the log data sort of into this format. If it's easy, you get it correct at the very first time. So you could relabel all the logs, all the data points that you have. And in this work, we find that we could, based on the relabel, to do some clusterings, then we are able to actually dissect students' learning strategies. For example, if you see 4 instances, students approach the easy problems, get it correct the first time, again, repeat the same types of the problems. We see the persistencies they are practicing this work. So this is just a snapshot on students' problem-solving strategies that could be detected. But what we learned later on is that using the sequential mining techniques, sometimes it comes with certain challenges, right? Because it could be arbitrary separations based on essentially the minimize the errors. Then you have to decide where's the threshold that you cut as the sequence, right? So we discovered that that types of modeling will have the challenges in terms of the interpretation. So then we move on to how do we actually detect the signals where they learn that could capture the details as well as the overall structure, right? So that we actually use the computer visions. They use the signal processing techniques so that you could see this wavelets, right? When we look at the pictures, how do you detect there is a contour of a building, a contour of a cup of foam? It's essentially the intensity of the signals, right? So that you could see the basic structures in the meantime, attach the meaning, what's the deep details. The more intense, more actions you see, the more data you see, more signals you see, the potential, the details, information. So we actually analyzed this for the longitudinal for multiple semesters and look into a larger scope and detailed scopes that we are able to highlight the potential programming analytics signals by the time they work on it and the intensities they solve the problem. So this is just, examples of all, and I hope that I will provide the slides, reference later so that you could refer to that, and I look forward to have more discussion with all you all. Thank you. How's my
All
timing?
right. Woohoo! You might be the first person who's ever given a talk and actually kept it to the length they said. That deserves a round of applause, but also a lot of information in there, especially that one slide that listed everything. I know this was pretty high level, but if folks have questions either about what was in the slides or just general questions about programming analytics that you'd like to ask Sharon, go ahead and put them into the chat. You could also raise your hand if you want to ask your questions verbally. Lots of things I want to ask, but let's give some other people a chance to formulate some things first. Well, we have a question already, but it's a very practical one, Sharon. I think some people would like to know a little more about Quizit, and I would like to hear if you're going to talk about that before just using it. What have you found to be useful about the system, and particularly with respect to analytics and any challenges?
So we designed a lot of the tools to help people learn in general, and in my case, it's in programming. And in this tool, Quizit, um, it gives us a greater control in the sense on the data logs. But for people or for institutes, we actually have a multiple institutes use it, and that the alternatives is if you could actually extract this data from the course management systems. Because the idea was actually coming from one of our instructors trying to put the quizzes onto their blackboard. And we figured, yeah, we do that too. But now we just want to focus on the problem solving, then you have to extract all sorts of other data. So we just designed the systems that mainly more focus on what we want. So they give you a greater length of control. So that's the challenges is now you have to manage it, right? So the practical reasons is you could get the data that you wanted.
Awesome. Sharon, I just realized maybe you want to stop sharing your screen so we can
Oh,
have your and
absolutely.
my and anyone else's face large. Um, so Oh, I was going to ask my question, but we've got another one come through the chat that I think is a nice one. So the question is, how does one measure the different stages as someone evolves in programming? For example, understanding a program, computational thinking, writing a new program. What are the things that you're finding to track that you help you see people progress as their understanding matures?
Mm, I would probably use my PhD advisor's work to explain this. The problem solving is in general. So how do you, at the end of the day, you want to be able to evaluate whether this program is correct or incorrect, right? So if you large amount of data that could actually be able to pinpoint to tell you whether the program's correctness. But looking at it, all sorts of different measures is trying to give a deeper interpretations on the state of the understandings. For example, you are able to interpret the syntax errors by looking into the different measures. But the correctness measures, problem-solving success, allows you to basically the good predictors enough across all different data.
Excellent. Um, So I see another good question that came in, and actually it ties a little bit with what I was going to ask. So I'm going to take the opportunity to ask mine, and then go to the one that is in the chat, which is, I was curious to know, with all of this work, what have you found most valuable and interesting that you've learned? So, for example, thinking about either the kinds of signals that are useful to track about how students are learning, or maybe a finding about what's really important for students. Yeah. So first, what has been sort of your big takeaways in terms of signals and findings, and then we'll move to the question in the chat.
Yeah, in terms of, thank you for the question. I think that's why I try to look at the programming analytics from the user modeling's perspective, because it only contains the two major components, the context and the learners. So the learners itself, that means we could actually just address how people learn. We could explore way more diverse how people learn, right? So I find that part is probably the most interesting. And if we actually change the word programming, we could actually look into the different fields of how we model how people learn in order to extract the signals in particular contexts.
And for your context, I'm just thinking, let me tie into the question there. Sort of, we have quite a few programming and coding instructors here,
Mhm.
and I think they're wondering, okay, this sounds great, but what would be either a takeaway in terms of this is the thing you should be aware of and keep an eye on how students are doing, or this is the kind of time that you'd want to intervene? What are some takeaways that you think would be useful for coding instructors to think about coming out of this work?
For coding instructors, um, the one thing I kind of sort of repeat talking about it is the programming problem solving success, right? So this one allows you to already examine the broader scales on the overall understandings. And if you look into big enough of the data, you are able to dissect the signals into the details on how they solve the problems into the short length in order to understand why they are just repeating doing the same thing, which is inefficient, right? So I think
Mm,
the for instructors, one of the key features is programming problems solving success.
okay, that's interesting. It's something that you could say is very specific to coding, or you could think about actually might have applications to other fields as well, but looking at really how they're trying to solve the problems.
Mhm.
Um, well, that wasn't a planned question, but it's kind of a perfect lead into what we wanted to do as just a little activity. And this is something we're trying out for the first time because a lot of times we talk, we have great speakers come and we hear words from them, but how does that go into practice was what we wanted to explore. And so I'm going to go ahead and see if we can share here is we have a small, not yet there. We have a small activity that we're going to invite you to engage in that actually addresses that exact question. And it's a ladder activity. So thinking about either from what Sharon just said or other things you already know about, what kinds of information would be useful to instructors to help support students learning to program? Why is that information going to matter? What would analytics potentially look like? And how could someone do something about it? And so we have this little ladder, and this was put together by our Learn doctoral scholar, Banji Lee. And it gives you just a nice little example. Of course, Zoom is hiding my screen. There we go. So, for example, one kind of information that might be interesting is what were common problems students had on a coding homework. That could be important to make sure to give feedback when there's not a single solution that would work. And some of the analytics perhaps discussed by Sharon might be comparing similarity of students' submissions with examples with each other's. In this case, you could look at the differences in the hard and easy problems and how quickly they were solved. And one way to maybe apply this would be to highlight key types of errors for student groups. Um, so it's an invitation, if we're going to put people into groups so they can have some conversation. If your group wants to talk about something a little different, that's fine. But we thought this would give a little framework for talking. I also thought that that wonderful, wonderful slide that Sharon had, which listed all the different kinds of analytics, I might have made a little Twitter post about it that I'll share if people want to refer to it. Um, let me see what else. A couple of details. This, now that we can see each other better, this is Fanji Lee, who came up with this activity, and she's doing some doctoral work in collaboration with NYU IT and Andrew Brackett, who is somewhere in all here. If I can't highlight you, but Andrew's there if you can wave. And this is part of our efforts in Learn to start to maybe try to do some of this work here at NYU and work with instructors. So if anything in here sparked your interest, whether you're someone working in academic technologies or a programming instructor, and you're interested, please reach out to any of us at NYU-LEARN or Andrew directly, also Fanji, and maybe we'll get something going. So I think with that, Chloe is going to put a perfect link to that copy of that slide, and then she's going to put people into breakout rooms. And if you're in room 1, you go to slide 1. You should have 3 or 4 other people to chat with, and we're just going to do this for maybe 15 minutes or so, and then hopefully come back and share a little bit. So thanks for trying the experiment with us, and hope to see you chatting soon.